So if you want to make a tuning table, I'll just go ahead and do that really quickly. So let's actually look at wave. So inside of the sample, we have this array. And so what this array does is it actually stores the sample. So if you're looking to make a tuning table, all you have to do is you can either convert it from text, drag it in, or you can apply an equation. So a lot of tuning tables that are microtonal will just be basic equations. So, but if you want to import literally anything, we're going to go to built-in modules, memory, and we're going to go ahead to table. And so this is actually an editable array. So then what you do is you click info and then function. And then you click the little table editor tab. So let's say that you want micro tuning and you want it to happen over a 1 octave range. So let's just go ahead at 0 and let's put in a very small value, you know, put a couple of zeros before that. Then we go ahead and click, wait. That's right, there's one more thing you get the thrill of doing because there's not an add button. You get the, so you can import table data, which is really nifty, but if you're doing it yourself, you have to say what your size is. So let's just say 32. I'm not actually going to fill out all 32 things. So then we do, you know, small number, slightly different, smaller number. So yeah, if you have a data file that actually has the scale you're looking for, you can just import that, and then you'll use this read block. And so the read block, when it receives a signal at the top input, will go ahead and write a value, or read the value, I mean, from whatever input's going to this integer input, the index. And then all you do is you just output it from here, and that's your value. So with what's going on here, it's actually playing back the sine wave. So just to show you that you can load in any sample you want, let's just go ahead and load in this drum sample that should sound familiar to a lot of people. Let's go ahead and set the pitch to be normal. Sorry, I've been going all around. Ooh, FM, that's right. So, okay, so now we have this classic sample. So you can literally import a drum sample, so you can import any type of data you want, whether it be for tuning tables, filter cutoff maps, anything. I'm just more of an equation person, to be totally honest, so I would just literally go in and change the conversions. The beautiful thing about Reaktor is that you can just open it and see how anything works. While we're here and we have it hooked up to the external modular, let's go ahead and process this drum loop with the built-in wave splicer wave folder, and then I'll show you how that works. Right now, we have this sample. Increase the fold. That's a little too heavy, so let's tilt it over to the next one. So that's a little more gentle, but basically just lets you get some like almost vinyl type saturation. So let's just put it on the gentle setting about 1/3 of the way, and let's go ahead and add back in the delays. Actually, no, let's just, so anyway, this is a PT 2399 base delay. Let's just, okay. I'm sorry, I know that this is kind of a chaotic thing, but I got a bit sidetracked there. So now I'm actually going to go ahead and show you how we can CV control a delay. So it'd be great if I didn't have to move that knob, right? And I can actually show you a neat thing that happens when you apply a negative control voltage to the, what is that? Synthrotech Echo. So we're going to take the rate CV, and we're going to connect it to the output on the Expert Sleepers number 4. So now, I've actually made a set of blocks, and if you go to my Gumroad store, or whatever, and you follow me, if you just type Gumroad, then Friedrichs Audio, let me just go ahead and type that in over here, and you can go ahead and get yourself these free hardware interfaces, actually. So let's see, Gumroad, woo! So anyway, if you just go ahead and type that into Google, the little storefront should show up, and then you can actually, when you follow me, you'll get an email, and then you can go ahead and get these easy interface blocks absolutely free. So what we're going to do now is we're going to use the easy interface output to control the rate. So the easiest way to do that is to just use the offset, and we're plugged into 4, so I'm going to wiggle the offset of 4. And of course we can control that from inside of Reaktor, so let's go ahead and add a basic Reaktor modulation. Okay, so let's go ahead and load up that external Reaktor block. Well, it's actually from the default library. I really like using this one. It's called the Rounds LFO. It's very, very simple, so it's great for examples. So let's just go ahead and load this up into the easy output module. And we're actually going to cut back to Reaktor. Sorry, I get really distracted sometimes. So we're just in the edit pane. You didn't really miss much. And we're going to drag Rounds LFO to modulation input A. And all of my blocks that I've been recently making all either have 4 or 8 modulation inputs compared to the standard 2. So it gives you much more flexibility. So we're going to click modulation A, and we're going to go ahead and route this LFO to control 2. And let's just go ahead and drag that up. And basically, as you can see here, this PT23 based delay is just ripping our sample up. And so now, feedback. Sorry, I love those delays. So essentially now, the cool trick you can do with this delay is that it should not have negative voltage applied to it, but you actually can do it. So there's absolutely nothing stopping you. So with this offset parameter, it goes positive and negative. So let's show you how that's done. Let's see if I can get it. There we go. And did you know that this delay had a built-in Geiger counter? Neither did I. Woo! So yeah, that's fun. So with this, you can take and push your hardware in ways you are definitely not meant to. And I absolutely love that. So that's the easy interface out. You also get the easy interface in, which of course lets you control the gain. So we can just totally destroy the input, but that sounds less pleasant. And that's just with a boring old drum sample you've heard I don't know how many thousands of times in the past. So right now, let's actually see, does anyone actually want to see something specific for this oscillator? Like, what do you really want to know about generating harmonics? And just anything at all, let me know, because that's what this oscillator is built to do.